Welcome back to Davos, live from the Congress Center. I'm Matthew Bailey, sitting here with my colleague Alexandre Karloff.
Hello.
Good afternoon, Alexandre. We had the pleasure to welcome you this morning for your keynote about cybersecurity fundamentals for space. Thanks a lot again. And you'll be with us this afternoon because we'll talk about cloud storage, cloud computing.
And cloud security.
And cloud security, of course, for space missions, especially commercial space missions. We have 4 speakers this afternoon before the panel discussion. First of all, we'll welcome Giovanni Pandolfi, who is already in the starting blocks, live with us. Good afternoon, Giovanni, from LeafSpace.
Good afternoon.
We'll be talking about ground segment as a service and how exploiting cybersecurity from there. Then we'll be moving on with Enrique Fraga from GMV, following up by Akash Patel from Microsoft, talking about data analytics on the public cloud. And we'll be finishing with Susan Linden and Christian Rückriegel from CGI about security considerations for cloud platforms in the space ground segment. What a program. We are thrilled because this is one of the most popular topics from the audience, from participants. Cloud migration, especially of legacy solutions for mission control, for ground systems that have been developed decades ago and that are now moving to the cloud with a lot of questions about interoperability, about security. And also the angle from new space players who are building natively their solutions, especially mission control software, in the cloud, benefiting from the free credits from AWS or Azure to start playing around and coding some applications for a very small amount of money. And these are obviously natively cloud compatible. So how do we merge these two worlds? What is the future of cloud computing on ground for storage, mission control, and so on? And also, what about the outsourcing of cloud computing, of services in general to third parties? As a service is a big trend in the industry. LeafSpace was among one of the pioneers of this trend, offering ground segment as a service, kind of making it very easy for operators to not have to reinvent the wheel and start from scratch their ground network. So we'll be talking about that with Giovanni, and yeah, let's go. Alex, do you have any?
I think we're all good. So
we're all good.
Really looking forward. So let's start.
Okay, Giovanni, please. Great pleasure to have you. The floor is yours.
Thanks a lot, and thanks for the nice introduction. Never had a so perfect introduction of what we do. So just a little presentation. I'm Giovanni Pandolfi Bortoletto. I'm one of the co-founders of LeafSpace, and now I'm Chief Strategy Officer. And today in this presentation, I would like to show you what we do and how we do it in order to be sure that our customer data is safe when it's transiting through our infrastructure, basically. Before that, just giving you a little bit of insight on what we do. So we are a ground segment as a service provider. We have been one of the first actually to adopt this name for what we do, because we really try to do on the ground segment what has been done with the cloud in the past, basically. So try to abstract whatever is possible to abstract from the infrastructure in order to provide a simple, effective, and efficient service to our customers. And we do this by 3 main products, basically. We have Leafline, that is a multi-mission ground segment as a service solution based on a shared ground station network. And I will talk a little bit more about that and the location around the world. But basically, it's a multi-mission. So we can use the same kind of infrastructure to support different missions with different requirements, different modulation schemes, for example, etc., in order to provide a cost-effective solution to our customer that don't need to build up an entire network for just 1 or 2 satellites, for example. And this is a really great service for technology demonstration missions, small constellation, or in general, a single satellite mission. When you want to scale and you are, for example, deploying a constellation, maybe the best option is to go to LeafSpace instead. There's another service. It's a dedicated ground segment as a service solution. So basically, we build up a dedicated network specifically designed, deployed, and operated for a mission. And this is, of course, comes with a quite huge advantage on the cost side, of course, because we can be more lean and deploy just station needed for a specific mission. Lately, last year, we actually expanded our support not just to satellites or orbital assets, but also to launch vehicles with this service that we call LVT. I know there's not a good name yet, but we are searching for a better one that stands for launch vehicle tracking. So it's a ground segment as a service solution mainly done for launch vehicles, and with which we actually supported Virgin Orbit in their testing launches that have been so far. And we are expanding also with other customers. So all these services are accommodated by some other values. There are, of course, the global coverage that we are building step by step, expanding our network, an easy and fast onboarding of our customers so they can start to use our service in an easy way and really, really fast. We have customers integrated with our APIs in a matter of afternoons, I would say. It's fully managed, so we control the full process and the full chain of the data, and we will talk about it in a few. And then it's flexible and scalable, thanks really for the architecture that we have built up. And one thing that is quite characterizing of our service is to have an optimized scheduling. So we do not let our customer to book a specific pass over a specific station that is not really scalable as a thing. But we optimize the scheduling, taking into account the different mission constraints from the different customers and missions, and try to optimize all these capacity need over our own network. So getting into the things of global coverage. So this is our network right now. I believe that you don't see New Zealand here. So we have 8 stations active right now and quite a few coming online in next year. And basically the thing is that with this global coverage, of course, we need to address also the cybersecurity on our side, of course, to be sure that all the data and the operation of the different ground stations are feasible, secure, and efficient, of course. Getting really on the topics that I would like to talk about, I would like to cover the aspect of the cybersecurity on the data that are transferred with and through our network. And to give you a glimpse of how we do it, this is a nice graph. So basically you can see on the left all our ground stations that basically have the similar kind of hardware in any location that we have that directly talks with the customer satellites through RF typically. We're also looking for optical and other means, but right now it's just RF. And then on the right instead, we have our customers basically. So the actual satellite operators with their own or commercial off-the-shelf mission control software with which they operate their satellites. What we do is basically providing a way of efficiently transferring data between the mission control software to the satellite and back. And to do that, we have what we call the network cloud engine. Is basically a theory of software or service microservices in general running right now on Google Cloud Platform, but we are quite cloud agnostic since the major part of our components run on Kubernetes right now, which is as different things to do, basically. The main one is the orchestrator. So basically manage all the activity of the entire network in an automated way. Then we have a routing capability. So in order to route the messages from the mission control software on one side and the actual satellite or the actual ground station in communication with the satellite on the other side, without the need to provide a specific connection from the customer to the ground station. And we will see later why this architecture is actually effective. And thanks to this architecture, we can activate different stations in a really, really fast way. So apart, of course, from the building part, that takes a while, but once the ground stations are built and active, they can be integrated and put online in the service really, really fast. And same way also from the customer side. So if we take this graph and we look about the kind of responsibilities, let me say like this, of the service, you can see that there is one part, this pink part, that is done by the customer. So the customer itself is, of course, the owner of the satellite and of the mission control. We do not perform any kind of direct operation of the satellite. This is a thing that the customer does, or the partners of our customers. What we do is to provide an efficient way to transfer data from the MCS to the satellite. And you can see that we have, between the ground station to the network cloud engine, we have VPN, or for some finding, and SSL TLS for some other part of the service, and then always SSL and TLS for the connection between the network cloud engine and the MCS. So I took the liberty to take this graph from CYSAT. I hope you guys have seen the white paper that they published. It's really quite complete, I would say, on what we need to do to understand what are the risks of managing a space asset, or in any case, to work in the space sector, because there are different points of attack, I would say, in the different components that compose the entire asset that need to be used to successfully operate and provide a commercial service. So you see from the little devil's face that there are different parts. So from the terminal to the satellite, even an impersonification or genuine spacecraft in some cases, and in general, there are always ways to provide an entry point for an attack case. So in our example, this basically comes here. So there are possibility, of course, to get unauthorized access to satellite function through commands that are done in such a way to enable that. But in any case, there could be some spacecraft function corruption, malicious software update. In some cases, even not any malicious, but having just a wrong software update and so on. And this, of course, takes part. This is, and also the focus of my presentation is about the data transfer, okay, from the MCS to the satellite. So these are one of the ones that can be the actual issues that one need to take into account. So regarding the data transfer, this is the focus of the presentation. So typically, this is the standard configuration of a space mission. Mainly, we can also do the example of maybe some years ago when a single satellite operator had an antenna on their rooftop of the office, where basically, so they were also the owner of the ground station. In this case, we can think that the actual antenna and the actual control of the antenna, for control of the antenna, I mean the motion, the tracking, and so on, is provided by a ground segment as a service provider. Then what has been typically done, or what is still being done today, is that the customer is also taking care of the baseband equipment. So basically, the equipment that receive a signal in IF and then extract bits and bytes, basically by the signal. So what was done typically is that have the encryption, if applied, the encryption was done directly at the baseband equipment. And it was kind of good because, it's something that was provided by the customer, in some cases installed at the segment as a service provider location. And so it was, the keys were managed directly by the customer, so it could make sense in some way. And then they have also a kind of possibility to have a LAN or a VPN between the baseband equipment and the mission control software. Of course, this is an approach that works when you have the ground station on top of your rooftop, or when you can deploy your own baseband equipment in the facility of your ground segment as a service provider. Of course, it's not so scalable, because as soon as your capacity demand in terms of passes per day increase, you need to have more access to more ground stations. And this means basically deploying different baseband equipment all around with all their key management system, and then have LAN and VPNs directly to your mission control software. This is possible to do, of course, but in a way you are taking care of a lot of things that maybe is not really needed that you take care of. And it's a kind of complicated process, because you need to manage all the VPNs, the LAN, and in general the keys, etc. And of course, if something breaks in the baseband equipment, is your responsibility. So it's not a responsibility for the ground segment as a service provider. So you need to be sure that what we are providing is actually reliable, effective, and efficient. So one thing that also I heard Alexander and the other guys talking this morning is zero trust. So with the approach that I just explained, of course, you need to trust yourself, of course, but also to trust your partner or whatever other partner you have in the middle between the ground station and your mission control software. Our approach actually on the data transfer is really on zero trust. So what we do is that we decided to do a little bit less of what is typically done on the baseband equipment. So as you see here, we do not do any encryption, decryption on the baseband, but we just transfer what is called actually the transfer frames to our customers. So basically, on the left side, what we do is taking, of course, the RF signal, down converted if necessary, do the demodulation. I'm talking about the downing. So do the demodulation, extract the bits, and then arrive basically just after the physical layer, or in some case in a part of the data link layer, where we can get these transfer frames. And then we move these transfer frames through the internet to the actual mission control software of customers, or they have a way to decrypt the data in the mission control software, or they have some other apparatus to do it. In this case, all the data that is being transferred through us is already encrypted. So we cannot get any access to it. We do not share any key with the customer. So they are basically not trusting us in this, and that's great, because of course, we could be a point of attack for our customers. In this way, instead, they manage the keys directly between the mission control software and their satellites, just through us, but looking us in a transparent way. And a part, of course, of this kind of advantage, the other advantage is it's really, really scalable. And as already said, we can apply the same kind of approach to different ground stations, always have these transfer frames as the base of our data pipeline. And the customer can keep their keys on their hand without any need for key distribution management or key distribution systems with us. And this, of course, gives a little bit more of courage or safety, I would say, also to our customers, because of course we are in any case encrypting all our communication, in which in the middle we transfer this data, but on their side they don't need to worry on this, because they are actually managing that part on their hand. Of course, this is the kind of ideal world where the customer is actually doing encryption or other means of security that are really also that could be also specific to their mission without trusting us. There are, of course, some missions right now, and I believe this is a good place also to say they are not adopting encryption yet, because maybe they are a technology demonstration mission and they don't need it in some cases. But of course, I believe that also through this conference, it's good to push even more in general, the space sector to adopt more and more cybersecurity guidelines, of course. So I just a little bit of conclusions. It's been quite fast, but so first conclusion is do not trust anyone. So and this is the principle of zero trust. You should be able to work in such a way that you can not trust anyone, and your architecture should allow that. So if your architecture instead rely on trusting, there could be already some security issues that you're already facing or that you're not facing yet, but for sure you need to take into account a terrorist, I would say. In some cases, we, in general, in the space sector, I believe that we easily say, yes, my link is encrypted, but actually without do an analysis on where this encryption is actually happening, which layer, which level. And also, typically, we need to understand really who is managing the keys, etc. If will be the actual managers of the keys or customer, that's totally not the thing that we want to do, because of course we will also be liable in case of a breach in our system for the actual loss of confidential data or something like that. So if we push on our side, our customers, but in general in the space sector, we need to focus more on the end-to-end security and also to analyze what is the actual root of trust that need to be put in place. And in general, last point, avoid key distribution with third parties as much as possible, because in some cases it's quite hard to do, but there should be more architectures allowing for avoiding this key distribution with third parties. Last point is any other conclusion that we can get, but I believe that's the good part of this conference to understand better what is around, what there is around in the space sector about cybersecurity, and try to adopt even more the guidelines that we already use in some other sectors. And with this, I've concluded, but I just want to show you, I don't know if it plays. Okay, it doesn't play, but it was a nice video of a pass through our ground station in Italy of a satellite that we have, but it's not working, no problem. The actual thing is working, so that's good. And here,
Giovanni,
I leave for questions.
actually, this is not working because we are using this very advanced PowerPoint as a background option and feature. So it's not
no
on your side. So don't feel guilty for that. Thank you so much for the presentation. Very interesting to see a bit how your infrastructure is actually set up. Let me ask. We have a couple of questions from the chat. I'll just ask by tackling the issue of the public cloud. You mentioned you were relying on Google Cloud, and you build up your service using Kubernetes. This is a great topic. Alex will cover it later. My question was about, did you do any benchmark of public cloud providers? How did you end up on Google? And what are the services, especially regarding security, that you may be using today or are looking at to use tomorrow? Or I don't know. Any details on your public cloud infrastructure?
Yeah, so we benchmark a few. I believe that the most work that we have done was on Azure and GCP, and actually looking at AWS more on a general level when we started. Actually, when we first started, we were not using Kubernetes. For example, we were just using some virtual machines and some software running on it. So it was much more, let me say, manual and more on the infrastructure as a service use for that. Then one step at a time, and I believe we finished this early last year, we moved everything on the major part on Kubernetes. I will say that the reason why we choose GCP was on a factor of simplicity for the kind of services that were there, and also to really have that is a kind of important note for a startup, really understand in an easy way what will be our cost structure for the use of the cloud. Actually, as we have built our own system, we are kind of cloud agnostic, and as you've seen, since we are basically acting as a data transfer provider, we do not push our customer to use one cloud or the other. Of course, it could make sense in some cases more efficient to have our customers on GCP, for example, or any other cloud provider that we're running on. But this is not something that we're pushing too much right now.
Yep. I'll just bounce off with the question from the chat. A question I was about to ask you is how complementary is your solution with typically AWS satellite solutions and Azure Orbital?
Well, it depends. Complementary in the terms that having different location and providing other capacity, of course, it's there. I would say that the concept of operation is a little bit different. As you have seen, we do we do part of the basement processing locally at edge, saying it fancy. So we do the modulation and the coding locally at our ground station. This way we can just transfer the right amount of data between the ground station and the customer. Azure and AWS are pushing more in another way because of course it makes sense with the cloud, instead of basically transferring the RF over IP and then let the customer do the basement processing through their own software, through other vendors' software. So we cover also that part. I would say that at the end of the day, it's quite interoperable from a customer to use different services. What I suggest to look is really on the operative side. So locations, the interfaces, and how the things are scalable enough, and also on the cost structure. But I would say, if the comparison is I need to have some passes over some location, that's totally interoperable.
Okay, thank you.
Thank you, Giovanni. So I'll handle a couple of more questions from the chat. So one question is about actually the overhead of encryption or VPN TLS on the real-time aspect. So actually the question says, do you lose any real-time guarantees when doing encryption with VPN or TLS?
So not so much. Actually, we've done some benchmark. Also, we will SSL and TLS and the VPN on the other side. On the narrowband part, we don't. So we can't see basically any difference actually in terms of latency. Because mainly the major part of latency that we have is really due to the network path. So for example, right now, I believe the highest latency that we have is between customers in Europe using the ground station in New Zealand, where basically the round trip is around 350, 400 milliseconds. And this is the major part. If we had adding the SSL or TLS, doesn't add too much of that. On the high data rate part, that could be a little bit more intensive, I would say, but we're now working to try to provide this kind of service really with just the latency that, of course, is needed and is good to have from the customer side.
Okay, cool, thanks. And another question was about whether you are relying on a proprietary infrastructure or on a public cloud service provider. So I guess the answer is you rely on some existing public cloud infrastructure.
Yeah, exactly. So of course, on the ground station part is all our proprietary infrastructure. So we use just our own infrastructure, and then of course for the cloud, it's good, a GCP, so it's public.
Okay, and maybe last question, looking into the time, I still have 1 minute. I was wondering actually, so from what I saw, you have, basically the customer, as you said, manages their own keys, and then actually you ensure that, this communication channel to the to the satellite. So how you mitigate and how you contain the risk of actually customer losing access to the satellite because somewhere in the middle of the infrastructure something breaks.
Yeah, exactly. So this is the main risk that we took into account when we designed this kind of architecture. So as you have seen, basically, by pushing the customer to adopt an end-to-end security architecture on their own. So basically, the data that they publish to us and they will transfer to the satellite is already encrypted. So in any case, we cannot access to that. And so this link between the satellite and the MCS is secure in some way. Then, of course, there are other risks that are mainly attacks to our own infrastructure that maybe doesn't make the customer lose their data or some attacker to steal their data, but actually provide a decrease of service on our hand. So probably we will lose a pass or some passes, but we will not lose the data. We will not, in any case, have so the attacker doesn't have an entry point on our side to get to the data and to decrypt that, of course, at least on the customer data. If, of course, the end-to-end security on the customer side is done in a, let me say, correct way. But then, of course, I just divided the two things in this presentation about talking about data transfer of the customer satellite on one side that are covered by this decision in the architecture. And then, of course, there is the other part that is the security of our own infrastructure and how we manage that part and the access of our own employees, for example, and then the customer to the interface that, of course, need to be is something that we have, but we are something that we are looking even more and more to address in a better way. And this is also part of the kind of collaboration that we have with CYSAT.
Cool.
Excellent.
Well, thank you very much. Unfortunately, we have to, I think, to wrap up.
Yeah, we have to wrap up. Thank you so much, Giovanni, for being with us.
Thank you.
And we'll see you later this afternoon for the panel discussion. So there are a couple of more questions. I think we'll take them in the panel. Thank you.
Perfect. Thank you, guys.
Thank you.
Thank you. Bye-bye.
See you later. Bye-bye.